thing is with an LLM, a large language model, it is a probabilistic model. So it kind of it just predicts what the next word will be. That's how they basically work. So given a large language model which is trained of an enormous amount of data, so the parameters within that large language model usually ranges from billions to like I think the lightest one from Mscc is around 7 billion, but they range up to 70, 120 billion and all that. So it is very heavy. And they normally know they have a vast amount of knowledge, but not necessarily knowledge about your specific use case or about a specific domain. In order to get that LLM uh, to know your specific use case, usually you can go through two techniques. The first one is RAG. The second one, which normally is going to be a bit more precise, it is called fine tuning. So training, then inference, and then training. So whatever you are going to train the LLM on, it's going to learn about it, and then it's going to give you an output on whatever you have trained it on. But the problem with fine tuning, which is called training, it is very expensive to do. So you need to have lots of GPUs, compute, and like I said, the 730 or 70 billion parameters you have to train. So it is a lot of data. And the next thing, which is kind of a drawback of fine tuning, it replaces the existing knowledge of the LLM. So it's not going to add up on what it already knows, it's going to replace it. So, for example, here, if we are going to train an English LLM on Japanese content, little by little it's going to forget that it knows English. It's going to only remember the Japanese content. But the advantage is that it's going to be much more precise, and it's going to be tailored to your specific use case. Now, in order to kind of circumvent the process of fine tuning, uh, we now do prompt engineering. So, RAG is basically a concept on top of prompt engineering. It is you're going to feed the LLM the context in your prompt itself. So here, for example, you just the guy is just telling the ChatGPT to replace each and every pronoun here with his cat's name. So the next time you're going to give ChatGPT a sentence, it's going to replace everything with meow. So meow likes to play with his friend meow. So you give the LLM the context, and then it applies that context on your prompts. So this is basically prompt engineering. First, you're going to give it the LLM an instruction, then you give it the context, and you get the assistant that is going to answer a question on the given context below. Then you give it the question that you want. It's going to give you an answer based on the context. I don't know if you guys have used ChatGPT plugins. ChatGPT plugins basically do this itself because ChatGPT was only trained up to with data up to 2021. So in order to get to know latest data, even for Gemini 2, they use a plugin which is going to search that data on the internet, extract that piece of text, feed it into the LLM, and then question the LLM based on that context. So, on the whole, this is what a RAG will do. But RAG is you're going to be doing it on a bigger scale, using specific database or even multimodal context, audio transcripts, news, videos, and all that. And these are going to be saved in a database, and the LLM is going to refer to that database. So this is basically a simple architecture for a RAG. So first you're going to have your vector database. This is so. For example, let's say if you have lots of documents, those documents are going to be converted into vectors. So LLM will take into context those vectors. It's not going to address the documents directly. It's just that those vectors will be saved in the vector database, and then when you launch query, that query is going to be encoded to vectors again, and find the most similar vectors will be matched from the database. Then you're going to get the context. That context is going to be fed into a prompt, so a template where you already have. You're going to fit in your context and your question, and then this will get into the LLM, and then you're going to get your response. So this is one pipeline which is you can call it kind of a production pipeline for Iran. So in this case, we are using LangChain, which is one a popular library for building RAGs, LM, and even transformations concerning LMs. You can also have the ability to build agents and kind of chain those actions together to perform what is specific to your use case. So in this case, there are two components to the RAG. First, you have the vector database. Then you're going to have the LLM itself. The LLM, it's very simple. You just load your LLM from Hugging Face. So you can have any kind of language model that you want. Normally from Hugging Face, you're going to get open models. So there's Mistral, Llama, Code Llama. There's tons of models now. You can use whatever you want. Then we build a prompt template. So the prompt template is basically kind of like this. You have your instruction at the top, the context, and then the question is going to go at the bottom. Okay. Once the template is being built, has been built, then you feed in. Then you're going to create the vector database where you're going to take all of your documents and first it goes through an embedding process. So all the words are going to be tokenized. Then those tokens are going to be converted to vectors and saved into the vectors database. When you launch your query, what happens is that first that query is going to be embedded, turns it into vectors again, and matched with that vector database. So basically what is going to happen is it's searching for specific words from your collection of documents. But it's not going to directly go into the documents and do the search. It's going to match the vectors. Once the vectors have been matched, and then it's going to know that these vectors come from this specific document or from this specific context. It's going to extract those texts from your documents and then use it as the context. Now the context is filled in. This is an example of prompt template. It's going to be filled in here within those parameters. The question is going to go here, and then this is just basically used as one big query for the LLM. So on a big picture, this is what the RAG is. It's pretty simple architecture. It's just that people who have been using prompt engineering, it's just taken up to a bigger scale. Now, first I'll show you guys a simple RAG which I've built locally on my laptop. Then we're going to move to something. It basically works a bit like Docker. So you have to pull in larger LLMs. You just have to write pull out. It's on, but it's only available on Mac and Linux. So if you guys want to use it on Windows, you have to go through WSL and then install. See, if I do this, yeah, it's going to give me all the available models I have installed with it. So Olama, you can also use it in production setting. It kind of simplifies the process of downloading and deploying an LLM. You just have to do Olama, pull, then if I want visualize, just need to pull that image, the LLM, sorry. Now, if you want to run that LLM, you just do Olama run. So I want to Olama. This is just going to run it. So then you can pop it directly from your terminal. And there's also, it also exposes an API, so you just reply, it's going to reply to you. So everything is locally, is being done locally, But in our case, we're going to use a simple run. So first, what I did is imported line chain, the line chain sets and libraries. This is going to convert the document into embeddings. This one is just going to call the Olama API. This is going to scrape the internet for all the content. So what I'm using is the express outflow for the similar registration, registration, and this is going to split characters from that text. This is also an embedding. It's going to convert text into embeddings. This is the vector database that I'm using. It's called ChromaDB. This is the wrapping service. It's going to retrieve the context, then you can pass in the equation terms. Here's, let me just put everything. Here's scraping the article and getting the text. This I'm initializing Olama and telling is that I'm going to use Lama 2 as my large language model. Next I'm going to this is going to split the document into chunks. So each chunk is going to have 500 characters. So it's just splitting that. And this one is first is converting all those chunks into embeddings using GPT-4 all embeddings, and then saving them into the Chroma vector database. This is just initializing the Olama API with it's connected to the